This is my 1957 Ford Fairlane 500, and I'm currently several months deep into making a video where I fix all of its many issues. One of those issues is a complete and utter lack of power, which I'd plan to solve with a 4-barrel Edelbrock carburetor. Because aftermarket parts for Y-block Ford V8s are unobtainium these days, some 50 years since the engines were relevant, I lucked out and bought a factory 4-barrel Thunderbird intake manifold off of eBay, which is intended for a Carter 4-barrel carb. However, I wanted something a bit more modern and ubiquitous, so I went for an Edelbrock, because you can still buy a rebuild kit for that thing at O'Reilly's for like $20, and I used an adapter to put it on the factory intake manifold. However, this adapter is the worst thing I've ever bought, and it came with two identical gaskets for the Edelbrock side and no gaskets for the side that mates up to the intake manifold. I also had to drill out some holes myself in it. Story for another time. And no matter what cars I searched in the part store systems to try and find a gasket that would work, I just couldn't find it locally, which just completely stalled me out for the day. Thankfully, I was able to use space-age technology in the form of frickin' laser beam and made my own custom gasket in a matter of minutes with this, the Creality Falcon 2 Pro Laser. Today I'm going to walk you all through the process to show you just how useful this technology can be. So the Fairlane issue is fixed, video coming eventually, but I am having the exact same issue with another vehicle, my vintage Sears 2-stroke moped. This moped has an aftermarket intake runner going to a Mikuni carburetor, and the flange interface is not good, leading to some nasty vacuum leaks in it running like this. Unfortunately, the only carb gaskets available for these are thin paper and don't have enough squish to make a proper seal, and they're just way too small for my shaky hands to cut one out of material manually. I can just never get the little thin spots, and they always end up leaking and all of that. And here's what we're going to use: the Creality Falcon 2 Pro Laser Engraver and Cutter. This is the 40-watt version. As you can tell, it says 40 watts there on the laser module. It actually comes with two laser modules. There's also another one that is just dedicated to engraving that's a lot smaller, but this is the big boy that can do engraving and cutting. And as you can tell, I'm a huge nerd. That was my test engrave on the basswood that it came with. Pardon all the noise. The dog he wants something. And also there's this huge octagon here because we're fostering some kittens. Actually, let's say hello to the kittens.
Hello. Hi. Yeah. So we have Suzuki, Kawasaki. Oh. Hi. What was the other one? Suzuki, Kawasaki, and I don't remember. But they're yeah, they were found in the backyard. Charity's been helping us out with feral cat control here, but they didn't have anywhere to foster these guys. So they're here for now. Aren't they cute? That one's a little stinker. Actually, that one's the best. That cat does not care. You can like spin that cat around in your hand and it just does not care. It is the most chill kitten imaginable. But this is the Creality Falcon 2 Pro. Now, Creality, yes, it's the same Creality as near as I can tell that makes the 3D printers. I have one. I have an Ender 2 Pro sitting on my shelf there. I do have another 3D printer from another company that I mostly use these days, but I'm not going to be buying anything else from that company because they started doing some shady stuff, and I'm actually looking into getting one of Creality's new enclosed 3D printers. Over on the left here, we have an air pump. This blows dust and debris out of the way of the laser. This is the vent tube. I usually put a box fan here and blow the air out the screen door over there by all the plants. The unit itself, it's got a debris tray here in the bottom. It's got supports for your material. It comes with this basswood test piece. You've got some red panels. I don't remember what kind of light these filter. Does it say? 455 nanometers. I'm not sure what that is. You got an on-off key. There's also an on-off switch, and there's also an emergency stop. So there's a lot of ways to turn this thing on and off. If you turn it on, you get a bunch of lights. That was very, very loud. The air is on right now. I'm going to turn the air off. You can hear it coming out there. Turn the air off. You can see it immediately lights an alert for not having air. It also has fire detection and lens dirtiness detection. If I just pull this forward, you've got reset button, USB-C for firmware updates, and then, yeah, all that cabling and stuff nicely managed on the gantry and whatnot. This comes partially assembled. It's pretty easy to put together. I got it done fairly quickly. I need to put this back panel back on because my cat jumped on it and knocked it out of place, so that's fun. Let me just... Reasonably silent stepper motors, self-homing, all of that fun stuff. It has sensors to tell if this is closed or not, and when it gets closed, the internal lights turn on and the very loud exhaust fan. Pretty nifty feature. Cut it off real quick. Take a look at the right side here. We got an SD card. You can load files on that and just hit start and it'll run off the first file on there. USB-C, which goes to a laptop. Power in, power switch. You can have the light on or auto. And then up here, there's another USB-C port for the integrated camera, which lives right up there. I have not used that much. It requires calibration, and the calibration looks like an utter nightmare to do. So I haven't gotten there yet, but basically, with certain software, you can use that camera to overlay. You know, you can put your material in here and virtually overlay your design on the material before you print it. I just use the frame option, which it traces out the outside of the print with the laser to make sure that I've got it relatively on my material, because I don't need to be precise. I'm just printing on this guy, which is a sheet of cork, rubber cork gasket material from O'Reilly's, so I can make whatever gaskets I want. This is fuel safe, oil safe, you know, valve cover gaskets and whatnot are all made from it, and it's nice and squishy, so this is ideal for our not very flat intake manifold flanges that I need to fix. So now let's talk about the software.
So Creality actually has their own laser engraving and cutting software called Falcon Design Space. It's currently in beta, so it's not completely feature complete. It's not completely done. Things might change after I make this video. And it did take a couple tries for me to get through the initial setup with my laser. I had to actually exit and reopen the program a couple times because it would just get stuck on menu options. I had to skip a couple of steps. It's kind of hit or miss at the moment, and it drops you off here in this sort of, you know, look at other ideas that people have, but we don't care about that. We have our own ideas. We have our own plan, and we're going to execute on that plan by coming over to Canvas. And let's see here. You've got options here for plane processing or rotary processing. Rotary processing is adding a third axis that sits in the middle and rotates objects around if you want to like engrave a bottle or something like that. It is worth noting this can't engrave metal. I had kind of hoped that I could etch aluminum, but even on its highest power, you can't etch aluminum. Part of your powers are set with this little stepped piece here. You set it on top of your material, and you use it to set the height of the laser based on if you're engraving, cutting, or cutting material larger than 6 millimeters thick. I've seen people cut through actual like plywood with this though, so it is pretty good with woods, or in this case cork, which cork comes from trees. I think that counts as a wood. So anyway, we're sticking with a standard plate, and we're going to go to image library. Sorry, we're not going to go to image library. We're going to go to import. We're going to import the picture that we took earlier. And by default, it's thinking that we want to engrave this image onto something, which is not what we want to do. We're going to use this as a tracing. First thing I'm going to do is rotate it so that the ruler is straight up and down. Now, in actual 2D CAD software, there are ways to scale things based on a known size. This software does not have that feature. It might in the future, but it does not have this feature yet. Something else I'm going to do now that I'm thinking of it is there a way for me to turn off snapping, auto snapping off? Yes, go into your settings, turn off auto snapping in the design space settings. We don't care. We don't want snapping. I set my units to inches because I'm going to go for an inch for my sizing here. So now we just go in here. We got 5 to 6 inches here. All right. I wish. We're going to go to drawing a line, and we're going to click and drag from 5 inches to 6 inches. Delightful. And then escape. Okay, there. Now we've got a line. That line is... let's see here. Size, line, height, 2.01 inches. So that line on our canvas that we want to be 1 inch is 2 inches. So I'm going to select all, and I'm going to resize all this stuff to about half of its current size. So I'm just going to click and drag. Yeah, that's something. And then I'm going to go and I'm going to click on my line that I drew again between 5 and 6 inches. It is now 1.41 inches. Okay, I didn't shrink it enough. I need to shrink it some more. How are we doing? I guess I could have just done a percentage of the overall size that I started with, but I didn't think that far ahead. Okay, so where are we at now? 5 to 6 inches, 1.16. So basically, you have a line that you know is going to be 1 inch, and you just keep resizing it in accordance along with your source photo here until you end up with dimensional accuracy. 1 inch. So now my 1 inch line is actually 1 inch, and along with that, my whole image here is the correct size. So we can delete that 1 inch now. I'm going to rotate this to a way that makes more sense, and now I'm just going to use the line drawing tool to trace out this shape here. There's no real need to make it take any dimensions of it. Now that our image is dimensionally accurate and that is a flat piece, we can just trace it. And I'm not even sure how precise I'm going to bother to be with my tracing. I'm just going to kind of click, 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 click. It stopped clicking. Oh, there we go. It was catching up. Click, 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 click. Okay. So now that I've drawn the outline, I'm just going to zoom back out and I'm going to delete our image, and that just leaves this outline here. Over here in layers, you'll see all these other layers. These can all go away. The only one we care about is the one that matches the color of our outline here, which is this pink one that says line engraving. I'm going to change that to line cutting, which for some reason sets my speed and power to 0. Oh, that's the problem. Connect the laser. There we go. There we go. Okay, now that the machine is connected, you have to choose a material. So for basswood board, the default speed for cutting is 150 and the power is 100. When I did that, it kind of charred the whole thing. So I'm going to set the power to 50 and the speed, I'm going to bump that up to 200. That will result in a cleaner cut through this particular material. And then I'm also going to go into the console. So the console here is straight up, is this G code? I don't quite know. I don't know enough about CNC, but we're going to do command 154 equals 0. And that will, yeah, that turned off the fire warning because this stuff smokes enough to make it think that the material's on fire. As you can see, it also gave me a suggestion since I have the air pump turned off. It told me how to turn off the warning for no airflow detection in case that is something that you need or want for whatever reason. A lot of these safeties are bypassable on a once per power on basis. Obviously not, it's highly dependent on what you're doing. If you're just sticking to the stuff that they include and that, you know, you're just engraving stuff on wood or whatever, then stick with their safeties. But in this case, I'm using a slightly more exotic material that has some special considerations. So we're going to turn off fire warning, and we're just going to keep an eye on it, like a hawk, like a falcon. I can't see a thing right now.
I think that might work.
Yeah.
Yeah. Just to try it out.
Had to print it at 200 times speed, 50% power to avoid absolutely crispifying material, but
Yeah. It didn't smell good.
does it fit? Oh, heck yeah.
It does in fact fit.
Dimensional accuracy. You want to know how I sized that?
With the tape measure?
So I had the tape measure there. I took the picture. I traced that, and then I drew a 1-inch line. Then I deleted the picture. Then I clicked on and then I rotated it so the line was vertical. Then I clicked on the line, and in the software, it told me the vertical height of the line, which was like 1.45 inches. So then I just selected all and shrunk it a little bit. Then I checked the height of the line again. It was 1.1 inches. So then I select all, and I just kept playing with the size of it until the line was 1 inch tall.
And it worked.
Yeah. I mean, actual CAD software, I could have just said, this is a 1-inch line. Please resize everything accordingly. But,
yeah.
You know what?
That worked really well.
And the reason why, and these gaskets aren't something you could buy. Like, they don't make a thick version of this intake gasket. And that...
I think the cork was the...
wherever it is, that manifold over there is not very well made. So...
I think the cork was the right decision.
Yeah, squashy.
Yeah. Squanchy.
And then, so the other thing was, I wasn't getting the nut tight enough.
That's what he said.
Oh no! I wasn't getting the nut tight enough because it kept hitting the metal here, and I was thinking that it was like tight, but it was just hitting this powder coating. So I knocked the powder coating off, so now there's enough room for the freaking nut to turn. So hopefully we'll have a running moped.
Hopefully you'll get your nut tight enough.
My gosh, it's a mess in here. Hang on, let's go wide angle. Woohoo! This place is a horror show. Nice.
Hopefully none vacuum leaks.
Yeah, hopefully. That'd be delightful if true. Sizable if factual.
True if big.
Yeah. Well, there we go. A problem that could not be fixed with off-the-shelf parts, but with the Creality Falcon 2 Pro, we were able to fabricate a solution. And this has helped with a lot of other projects like the base gasket that I mentioned earlier for the 57 Ford, because for some reason, Carter carburetor stuff is just absolutely unobtainium these days. Go figure. Links, of course, are in the description, probably, and maybe a code on screen, maybe. We'll see what they get back to me with. And if you're interested in buying this thing, get a hold of me. I don't know what I want for it, and it'll be on Marketplace.